Okay, now let us start series of lecture on AIC MCQs. Here the first one, it tells about the clipping level in op-amp is determined by. The clipping level in op-amp is determined by, options are given to us: AC supply voltage, control voltage, reference voltage and input voltage. AC supply voltage, control voltage, reference voltage and input voltage. So in the previous lectures we have studied about what is meant by clipper and clamper. We know that clipper is a kind of circuit which is mainly used for clipping. Clipping means what? Removing of what? Removing of the AC signal. That removing of the AC signal which is unwanted, that will be taken with respect to what? There will be one reference voltage will be there. With respect to that reference voltage only, it will be clipping the unwanted AC signal. So here the option is C. If you see the explanation here in the bottom, it is given that the clipping level is determined by the reference voltage which should be lesser than the input voltage range of a op-amp. Which should be lesser than the input voltage range of an op-amp. What is the input voltage range of an op-amp? It means that if you give some input voltage, we know that to some particular level the op-amp is going to produce the output, and after that one the output of an op-amp is going to get saturated. So output of an op-amp is going to get saturated means what? Even though you trigger some input voltage, after reaching the saturation, you are not going to have a good output, means output will not be increased, output is going to be saturated. So now here what is meant by the input voltage range? So here the input voltage range is nothing else but simply it tells about the range of the input which is in the operating period, which is in the operating phase of your particular op-amp. So that's the input voltage range. So your option is what here for this one? For this particular question, your option is, excuse me, for your particular question, the option C is the correct one. Option C is the correct one. Then the next one. In the positive clipper, the diode conducts when? In the positive clipper, the diode conducts when? Some options are been given to us. What is V in less than V reference? V in is equal to V reference. V in is greater than V reference. None of the mentioned. So now let us see here. In the positive clipper, the diode is going to conduct when? So what is this diode actually? The conduction of a diode takes place whenever the diode will have minimum cut-in voltage. The diode is going to conduct whenever it has got minimum cut-in voltage. So now as per this particular circuit, the circuit which is given to us is a positive clipper circuit. In the positive clipper circuit, what happens? The diode is going to conduct whenever the input voltage which is supplied to the circuit has to be equal to some reference voltage. Regarding the reference voltages, we have studied in the class what is meant by reference voltage and what it is an actual fixed value of the voltage. So that reference voltage we are talking here. So at least the input voltage has to be equal to some reference voltage, then only your circuit is going to become active. So now here in the positive clipper, the diode conducts until V in is equal to V reference during the positive half cycle of the input, because whenever the V in is lesser than V reference, the reference voltage at the negative input is higher than the positive input. So always keep in your mind, we know the diode is going to conduct, or diode is going to become forward bias whenever it is going to be both positive has to trigger the diode. Positive cycle has to trigger the diode. That's why the second one is given here. In the second bottom line, you can see that whenever V in is lesser than V reference, then what happens? The positive cycle will be lesser than the negative cycle. So the diode will not be conducting. Diode will be conducting whenever the V in is almost equal to the V reference. So your option here is, what is your option? What is the option here? The second one is the correct one. Whenever the V input is equal to V reference, that is your answer. Then the next one. What happens if the potentiometer RP, what happens if the potentiometer RP is connected to a negative supply? Here, we know what's the potentiometer. Potentiometer is a kind of circuit which is mostly here, which is used for checking of this potentials and different varying that different potentials, and also you can trigger. Why? Because it's a varying potentiometer. You can see, whenever you can see here this kind of uh, excuse me, where is my, yeah, this one. Whenever you see this kind of arrow mark, it means what? Here this particular resistance is varying. Your particular resistance is varying. Whenever the value of resistor varies, then definitely the potential across this particular resistance also varies. And what is that one is connected to? It is connected to the power supply. It is directly connected to the power supply. So now let us enter into the question. What happens if the potentiometer RP is connected to negative power supply? If a potentiometer is connected to negative power supply, what is going to happen? Let us see. If the potentiometer is connected to negative power supply, that is minus VEE, instead of positive power supply, the reference voltage V reference is going to become negative. Reference voltage will, what to say, its polarities are going to change. Its polarities are going to change right from positive to negative. As a result, the entire output waveform above minus V reference will be clipped off. Why the output voltage is going to clipped off? Because now your reference voltage has become the negative. So that's why the option C is the correct one. Whenever we connect your this one to the minus V reference, it is going to be clipped off. Excuse me. Yeah, I found my pen. So option C is the correct one. Now the next one. What happens if the input voltage is higher than reference voltage in a positive clipper? Now the next question. We have seen up to now, in whenever the input voltage is equal to reference voltage, the clipping happens. In the second one we have seen here. Whenever the input voltage is equal to reference voltage, then what happens? The diode is going to conduct. Now the question is that what is going to happen if the input voltage is higher than the reference voltage, means input voltage is greater than the reference voltage, then definitely what happens, that too, whenever you are talking about a positive clippers, so see now, whenever your input voltage is going to become higher than your reference voltage, that's V reference, the the op amp will be operating in an open loop, and the diode becomes the reverse bias. The diode is going to become reverse bias. Whenever the diode is going to become reverse bias, ultimately there will be a detachment of op amp with this particular output. Thus the output voltage is equal to the reference voltage. So ultimately the answer is your output is going to become equal to your reference voltage. Option A is the correct one. The next one. A positive small signal half wave rectifier can, what does a positive a positive small signal half wave rectifier can do? So see here, now we have studied about the half wave rectifiers, bridge rectifiers, full wave rectifiers, and different kinds of rectifiers. We have studied all those things. So now let us see here with respect to the positive small signal half wave rectifier. What is this positive half wave rectifier? It is a circuit which will rectify the signal with respect to the peak values. Peak values means what? Down to few millivolts. It is going to rectify the signals. You know what is meant by rectification. You have studied it in the basics over here. So normally if you want to know about rectifiers, we being an electronic engineers, we are supposed to know what is the main aim of a rectifier and what that particular rectifier does. So as per our particular this one, what to say, rectifier means what? It is a electronic circuit which is going to convert any kind of AC current into DC current. Where it's a circuit which is going to convert an AC into DC. So that can be done here. So ultimately rectification is been done with the help of rectifiers. And you can also know that if you want to see about learn about rectifier means what? First of all, it is a kind of diode which converts alternating current to the direct current or AC to DC, and only that has to flow in one direction. That's most important one. This current which is converted from AC to DC is going to flow only in one direction, whereas your AC regularly will be reversing. That thing we all know, that DC will be flowing in one direction, whereas your AC signal will be reversing right from the positive to negative. So our question is what is this positive small signal half wave rectifier, and how it has been used for what applications, and some values have been given over here. So just now we have studied that your rectifier is a circuit which is mainly used for conversion of AC to DC, and here that AC to DC will be what? Rectification of the signals will be done with the help of both the peaks. Both the peaks means what? You'll be having the positive peak and also negative peak for the AC signal. So that's AC signals rectification will be done with respect to very small millivolt voltage or millivolt potentials. So here answer C is the correct one. Diode in small signal positive half wave rectifier circuit is used as what? Diode in a positive half wave rectifier circuit is used as what? Just now we have studied that. What is a diode? It's simply, just now I have told you the definition of rectifier. Rectifier means what? It's a circuit which will be converting from AC to DC. And after that I have told the another definition. Rectifier is a diode which converts AC to DC. Means what? It's just acting as a simple diode. It is just acting as a simple diode. Why I have told simple diode? Because I have told while explaining the previous question, here rectifier will be acting as a diode in converting AC to DC, where DC will be in only one direction. DC is going to be in only one direction. So it is an unidirectional one. So ultimately it acts as an ideal diode. Apart from all those three options which are given to you, all those are incorrect, whereas the first one, ideal diode, is an correct one. So now let us enter into the explanation. The diode acts as an ideal diode because the voltage across the on diode is getting divided by the open loop gain of an op amp. The voltage will be getting divided as an open loop op amp. As the input voltage starts increasing in the positive direction, the output op amp also increases positively till the diode becomes forward bias. Is it fine? That's what we have seen. It's an op amp which is connected with a diode. So ultimately what has to trigger the input voltage? If the input voltage is increasing, the output also gets increasing. Why? Because it's an amplification, and the increase of the voltage at the input will trigger the diode only when the input voltage of an op amp, or whatever the input voltage you have triggered or supplied, that has to be equal to the cut-in voltage of a diode. Whenever that cut-in voltage of diode takes place, then only the diode is going to be turned will become as a forward biased one, and it turns on, and it unidirectional operation takes place. So diode in small signal positive half wave rectifier, it acts as an ideal diode. Option A is the correct one. How to minimize the response time and increase the operating frequency range of an op amp? How to minimize the response time and increase the operating frequency of an op amp? So I think in the previous lectures we have studied about what is the response time in an op amp. Response time in op amp. I hope you remember that one. What is meant by response time in an op amp? So here, if you see what is the response time in an op amp, we talk here about the settling time. In fact, we are talking about the settling time. Settling time of an op amp is nothing else but it is defined as what? The time which takes the output to respond to a change in the input. Response time means what? Whatever the time is taken by an op amp in order to produce the output whenever the input is changing. As the input changes, we know that the output is also changing. So what is that amount of time in order to settle and give out an output whenever the input changes? That is called as a response time. Response time is what we are talking about. What to say, it is like uh, we are talking about the settling time, or how much amount of time a particular op amp takes in order to produce and give one exact output level depending upon the changes at the input. So that is called as a response time of an op amp. So that response time we are talking here. How to minimize response time and increase the operating frequency of an op amp. Means if you are having very lesser amount of response time, it is it's good to have a good better performance of an op amp. Whenever the response time is less, then definitely the op amp's performance also will be increased, because within lesser amount of time the op amp is going to produce an output with respect to the change in input. So now let us enter into this particular question now. Some options are given to us. A positive half wave rectifier with 2 diodes, positive half wave rectifier with 1 diode, negative half wave rectifier with 2 diodes, negative half wave rectifier with 1 diode. So now let us see the explanation here. Negative half wave rectifier circuit with the 2 diodes are used so that the output of an op amp does not saturate. The output of an op amp does not saturate, thus minimizes the response time and increase the operating frequency range. What happens if an op amp is saturated? The output is going to be idle. The output is going to be idle. So ultimately what happens? You are again supposed to reset the operation of your circuit and make the circuit to work. So ultimately we are supposed to make sure that the circuit is not saturated. We should make sure that circuit is not saturated. That's why we are going to use here negative half wave rectifier with a 2 diodes. Whenever one diode is off, then other might come in help to make that circuit to be in active mode. Even though if one diode is reverse biased, one of the diode is going to be forward biased, and it will help the circuit to be in active mode. So your answer C is the correct one. Eighth one, why a voltage follower circuit is connected to the output of a negative small signal half wave rectifier. Why we are going to connect a voltage follower circuit to an output of a negative small signal half wave rectifier. So we know that what is a voltage follower circuit. The main thing is that in the voltage follower circuit we need to have, we are going to obtain an unity gain. The gain of an voltage follower is unity gain. It means whatever the input is given, the output is also same as the input. The output is equal to input, so that's why the gain of that particular voltage follower is going to be equal to 1. So let us see the options. Now here, due to non-uniform input resistance, due to non-uniform output resistance, due to uniform output voltage, and none of the mentioned. So here the option will be the output resistance, which is mainly non-uniform. Why the option non-uniform output resistance? Because the output resistance of a circuit is non-uniform, because as it mainly depends upon the state of the diode. The diode state, just now I have told about the diode and how it operates in the forward and reverse bias. So your output resistance is mainly depending upon what? The diode operation. That is, the output impedance is low when the diode is on and high when the diode is off. I hope you understood this line. Whenever the diode is conducting, whenever the diode is forward biased, then what happens? It will be a continuous flow of voltage. The continuous flow of voltage takes place. That's why voltage is flowing means what? Definitely the impedance of that particular circuit is very less. If the voltage is not flowing across that particular circuit, means the impedance is very high. So ultimately we are looking for this kind of operation where your output resistance is not uniform. Your output resistance is not uniform. That's why voltage follower stage is connected to the output of a negative small signal half wave rectifier, so that this non-uniformity will be minimized to some extent. So your option B is the correct one. Your option B, excuse me, yeah, actually I'm unable to find my pen. It's very small dot which it's been appeared on my PPT, but the symbol for you which you look over there is a bigger one. Okay, the next one. Here, a circuit with a predetermined DC level is added to the output voltage of an op amp is called as. This thing yesterday we have seen, and in the previous lecture we have seen what is a circuit which we have seen over there, which is mainly related with the DC signals. Yesterday in the previous lecture I have told that uh, clipper is what? Clipper is a circuit which is mainly used for clipping the AC signal, unwanted AC signal, or what to say, removing of the AC signal. Whereas your clamper is a circuit which is mainly used for adjusting the DC voltage levels. Is it right? Your clamper is a circuit which is mainly used for adjusting the DC voltage levels. So here, what is the circuit which is related with the DC voltage level? It's a clamper. So clamper circuit will clamp the output to a desired DC level. Adjusting the DC level means what? Why are we going to adjust? In order to get a desired DC level. So that's the reason. Among all these four, the option number first one is the correct one. Option A is the correct one. That's clamper. The circuit which is predefined, a circuit with a predefined determined DC level is added to output voltage of an op amp is called as a clamper. So option A is the correct one. Next one. An op-amp clamper circuit is also referred as. Op-amp clamper circuit is also called as DC inserter. It's a direct question. It's the other name of a clamper circuit. The clamper circuit which has been designed with the help of an op-amp is called as an DC inserter. It's a direct question. It's the most important question. Many times it has appeared in many different competitive exams. So your answer is DC inserter. Option B is the correct one. Let us see what is the explanation for this one. In an op-amp clamper circuit, a predetermined DC level is deliberately inserted at the output voltage. Why we are deliberately inserting a DC level? In order to get a desired output, in order to get the desired DC output. For this reason, clamper is sometimes called as an DC inverter. So option number B is the correct one.